everyone. So welcome to my YouTube channel Zenith GATE Mechanical. So in this session I will talk about the solutions for those problems which came into the GATE 2026 mechanical paper. Let's move to the next. What are the questions that they have asked from the strength of material subject? So the first question they have asked from the SFD and BMD. So they have given one particular cantilever beam which is subjected to various loading condition. One is the point load, another is the moment. So you have to identify out of these four options which one will be the correct shear force diagram and the correct bending moment diagram. Okay. So what is the question? A cantilever beam of length L is subjected to a concentrated load P and a moment M as shown in the figure below. Neglecting the mass of the beam. Okay, so you are not considering the mass of beam. Which one of the following option is correct? Representing SFD and BMD. Fine. So first of all, what you will do in these type of problem, first of all, you will calculate the reaction at the support. Okay. So as this is a fixed support, so can I say how many reaction will come? One will be the vertical reaction RAY, another will be the horizontal reaction RAX, and another will be the moment. Because the fixed support will restrict all these three motion, horizontal motion, vertical motion, as well as the rotation, which is nothing but moment. So I have assumed the direction of RAX, RAY will be like that. Okay, so you can assume in any direction. If your answer is getting negative, so you just change the direction. Now, so what I will do, first of all, I will use the equilibrium equation, summation of force in x direction 0. That means I can say RAX value will be 0. Why? Because there is no force acting in the x direction. Similarly, summation of force in y direction 0. What are the force acting in y direction? One is the upward positive and P will be downward negative. So RAY is equal to P. You have got the reaction at A point in the vertical direction is P. Now, next thing what you will do, you want to calculate the moment about A. So you will take the summation of moment about A is equal to 0. There is a concentrated moment you have assumed. So now, which is a moment in this direction. So let us suppose this is a positive. So MA plus this is also creating a moment in the same direction. So PL by 2 because the force into this distance. Now this is a moment which is in the opposite direction. So can I say this value is nothing but minus M, where M is nothing but PL by 2. So you got the moment about A point is equal to 0. So you have calculated first of all the reaction at the support. So that means only one vertical reaction will be there even in the, this is a fixed support. Okay, because the moment about A point is coming out to be 0. Now, so out of these four options, you have to identify which one will be the correct. So first of all, you will go for the SFD. So let me take these points A, this is B, and this will be C. This is A, and this will be B, and this is C. Okay, so at A point, what is the vertical force is acting? The force is acting as a P. Okay, and then there is a no force, that means it is a constant. Then P force which is acting on a downward. Okay, and after that, if you see there is no vertical force which is acting over this portion, that means there will be zero shear force. Okay, so for the portion L by 2 or for the portion AB length, the shear force will be like this, and this is a positive. Okay, because on the left side it is a upward and right side it is a downward. So as you know the direction, based on the direction of the shear force, this will be positive. So out of these option, which one will be correct? So these C and D option will be eliminated. Either the option A is correct or the B option will be correct one. Now you will check for the BMD. What is the correct BMD diagram for this particular question? Fine. So to get the variation of the bending moment diagram, what you will do? First of all, you can take any section. I will take a section XX at a distance of X from this fixed end. That means for portion AB, can I say the moment at X is nothing but what are the forces will create a moment? Okay, So this force is already 0. This is moment is 0. So RAY, which is nothing but P only. So P into X. So if you take at X is equal to 0, that means the moment at A point, which will be nothing but 0 only. Fine. If you put at X is equal to L by 2, how much you will get? P into L by 2. So that means there is a linear variation for the portion AB. For the portion AB. Similarly, if you will check for portion BC. Okay, so now what you will do again, if you will take a section XX at a distance of X from the free end, so there is a only concentrated moment is active. So this is moment is constant for the whole length. So can I say for the portion BC, the moment will be constant, which is equal to PL by 2. Now you can draw the bending moment diagram also. So what is the moment at the C point? There will be a concentrated moment, which is nothing but PL by 2. So whenever you will see there is a concentrated moment, you will see a vertical line in the bending moment diagram. As it is a sagging bending moment, that's why you are getting as a positive bending moment. Now, this is a constant bending moment for the portion BC, which is a constant only. Constant only. Now, there will be a constant bending moment till here. Now, at the B point, which is nothing but you have already calculated here at X is equal to L by 2, which is PL by 2 only. So this point, the bending moment is PL by 2. What is the bending moment at A point? The bending moment at A point is 0. Now, how this bending moment is varying? This is varying x to the power of 1. That means there is a linear variation. There is a linear variation. This is positive. This is also positive. So what will be the correct bending moment diagram? So out of these four options, the SFD will be this one, and the bending moment diagram will be this one. Okay. So the correct bending moment diagram will be the option. Very good question. So the option A is the correct answer for this question. Fine. Now let's move to the next question. Let's move to the next question. So this is also a 2 marks problem. Two structural members are connected by a hinge and they are externally loaded as shown in figure. Okay. So there are the two members. So for example, this is one member and this is another member. They are joined together through a hinge joint and they are loaded with these particular loads. A and B are roller support. C is a pin joint. Neglecting the mass of member, the magnitude of vertical reaction at the C. So you have to calculate what is the vertical reaction at the C. Okay, at this joint is a hinge joint. There will be two reactions. One is the horizontal, another is vertical. If they will ask about the net reaction or the reaction at C, so you have to take the reaction at the C in the horizontal and vertical. Okay. And then you have to calculate the resultant reaction. But they have only asked about the vertical reaction. And one more thing, there is no horizontal force is acting, so definitely this reaction will be 0. So that's why they have asked only the vertical reaction at this E point. Fine. Now, so suppose if I will consider this is a reaction at the C point and this will be the reaction at A point. Fine. First of all, you have to understood this is basically a hinge joint. Okay, there is at the hinge the moment will be 0 because it cannot resist or it cannot restrict the rotation part. So the moment will be 0. So first of all, you will calculate the reaction by assuming the moment will be 0 at the D point. Moment will be 0 at this point. So what are the reaction? One is the RA and this will be RB and this will be RC. There will be a horizontal reaction, but there is no horizontal force. If you take summation of force in x direction, it will automatically come 0. Only 3 vertical reactions are there. Now, at the hinge, as you know, the moment is 0. Moment is 0. Fine. So if you take the summation of moment at D point is 0, what you will get? RA into 1. Okay, RA into 1. I'm taking the moment about the hinge joint, which is nothing but D. RA into 1 minus this force is basically creating a movement in this direction. So can I say that 10 into 0.5 is equal to 0? So RA value you will get as 5 kilonewton. RA value you will get as 5 kilonewton. The reaction at A point is 5 kilonewton. Fine. So now what you will do, RB and RC you have to calculate. So to get the value of RC, because what is the question? You have to calculate the vertical reaction at C. Now, if you take the moment about the B point is 0, so as you know that RA is already, 5 kilonewton. Okay, so then you can easily get the value of RC. Now what I am doing, so I will take summation of moment about B is 0 to get the reaction at C point. Reaction at C point. So what is this? RC into 0.8. Fine. I'm just taking this distance because I'm taking the moment about B. So this is 0.6, 0.2. So 0.8, which is in the anti-clockwise. So anti-clockwise I'm taking as a positive. So this 25 will take as a clockwise. So it will negative 25 into 0.2. Now the reaction at B point, it is already, you are taking a moment about B point. So this is passing through this. So there is no moment. So the 10 and RA will be the another force which will create a moment. So which is nothing but minus of 5 into 1.2 plus 10 into 0.7, because this distance is 0.5, 0.7, total will be 10 into 0.7, which is in the anti-clockwise. RA will create a clockwise, that's why I have used the minus sign. So 5 into what is the distance? 0.5, 0.51, and 0.2 is 1.2 is equal to 0. So only one unknown is there. So from here you will get the value of RC. So this is 5 and this is nothing but 6, and 10 into 0.7, which is nothing but in negative. So this will be 7. So this is 4. So RC value you will get as 5 kilonewton. 5 kilonewton. So let me check. Yeah, option A is the correct answer. Choice A is the correct answer.